This is a typical example of a question on cumulative frequency table, where you'll be asked to complete the table. Okay, so you'll be given a data set. These are the ages of patients. So we have 9, we have 1, we have 11, we have 13, 15, 15, 15, 17, 18, and 20. Then you'll be asked to complete the frequencies, compute the less than cumulative frequency, and also compute the more than cumulative frequency. All right, so now for 9 appears how many times? 1. So you write 1 over here. For 11 appears how many times? 2. So we write 2 over here. For 13 appears how many times? 1. So you write 1 over here. For 15 appears how many times? 3. 1, 2, 3. Then you write the 3 over here. For 17 appears how many times? Once. Then you write 1 over here. For 18 appears how many times? Once. Then you write the 1 over here. 20 appears once. You write the 1 over here. Then you do the less than cumulative frequency. Remember, the principle still holds. But then there is an addition you may have to add on the table. You may have to add total here so that you can compute the total frequency. But you will not do total for the less than cumulative frequency. You would not do total for the more than cumulative frequency. Then you use the various principles to get the total frequency. The total frequency is equal to the first more than cumulative frequency. Again, the total frequency is equal to the last less than cumulative frequency. So what you get for the total will be equal to this less than cumulative frequency. It would also be equal to the first more than cumulative frequency. Then you use the vertical approach to get the less than cumulative frequency. The vertical approach upwards, downwards to get the less than cumulative frequency. Then the vertical approach, summation from down upwards to get the more than cumulative frequencies. Let's move on to the next. Now we are going to look at how to calculate for median in an ungrouped frequency table. How to calculate for median in an ungrouped frequency table. Now when we give you an ungrouped frequency table, first of all, how are you going to know it's ungrouped? You check the variable column. Okay? Now, most of the time, the variable column will be the first column on the question table or the original table that will be given to you in the question. So over here, you see the variable column is the first. Okay, so the body temperature, this is the variable column. And then the number of patients represents the frequency. So how will you know the data? The table that has been given is on group frequency. You check the variable column. If the variable column, the values there are single units or discrete units, like whole units, they are not in intervals or ranges. They are not appearing like this. So they are not appearing like this, maybe 10 to 12, maybe 13 to 14. They are not appearing like this. Then it's an ungrouped frequency table. So over here, this is an ungrouped frequency table. Why? The variable column is not in class intervals or classes or ranges. Okay, so this is an example of an ungrouped frequency table. So the table will be presented to you like this. Then you'll be asked to calculate for the median. Now, if you are given an ungrouped frequency table to calculate for the median, one principle holds. The principle is that redraw the table again. This time, there will be 3 columns. Redraw the table again. This time, you have 3 columns. The third column that you are introducing, you will call it the cumulative frequency column. And that is why we learned the cumulative frequency before this lesson. Okay, good. So the principle is that if you are given an ungrouped frequency table to calculate for the median, you have to redraw the table again. This time, there will be 3 columns. The third column you are introducing is called the cumulative frequency. Okay, good. So we have the cumulative frequency. So you see here, we've introduced the cumulative frequency. On the original table, usually, the total computation will not be done. So you would have to draw the table again, introduce the third column, then you do the totals. So you see, we've done the totals over here. Okay, so you are going to sum up all the frequency. Remember, you can't do total for this. We do not do total for this. The same thing we learned in median. In median, the variable column, we don't add it. It's not done. So you write the total under this. Then you come and write your n or your summation of f over here. When you sum up all this, you get 15. Now remember, there are times that in the question, the examiner can tell you, okay, the body temperature of 15 patients attending a clinic were recorded as follows, and tell you 15 patients, but still, you still have to confirm, sum up yourself to be sure that it's actually 15. Don't assume 15 is in the question. So in your computation, you go further to use the 15. Sum it up to be sure that it's the same 15 that you have. Then you use the same principle for cumulative frequency. But remember, here, the cumulative frequency we are using is the common one, which is the less than cumulative frequency. Okay, remember. So here we are using the normal cumulative frequency, which is the less than cumulative frequency. So you can simply use the vertical approach. So you see here is 15. So once here is 15, you see the total frequency too is 15. The first cumulative frequency is equal to the first frequency. So here is 1, here is also equal to 1. 1 plus, if you want to get this frequency, 1 plus 2 will give you 3. If you want to get this, 1 plus 2 plus 3 will give us 6. If you want this 10, 1 plus 2 plus 3 plus 4 will give us this 10. If you want this 13, 1 plus 2 plus 3 plus 4 plus 3 will give us the 13. If you want to get this 15, 1 plus 2 plus 3 plus 4 plus 3 plus 2 will give us the 15. Okay, good. So you redraw. So the principle is that for an ungrouped frequency table, to calculate for the median, redraw the table again. This time, there will be 3 columns. The third column you are introducing, we call it the cumulative frequency column. Now, after you've done the table, there is a general formula that we use. After you've done your table with 3 columns, there is a general formula that we use. Now, the median position is equal to n plus 1 over 2 position. Okay, that is for ungrouped frequency table. The median position is n plus 1 over 2 position. Now, let's check. What is the n? N is equal to, from the question, n is 15, but you also have to add the frequencies. We added the frequencies. Someone will ask, how did we get the n? We added the frequencies, the number of patients. You add all of them. So over here, we add all of them to get the 15. So n is equal to 15. Then you interpolate that into the formula. So we are going to get 15 plus 1 all over 2. That will be 16 over 2. That will give us 8 position, 8 value, or 8 position. Now, the 8th position, what are you going to use it to do? You go back to the cumulative frequency. So the 8th position, you go back to the cumulative frequency. So you come to the cumulative frequency, then you check. Okay, the 8 is greater than 1, skip it. 8 is greater than 3, skip the 3. 8 is greater than 6, skip the 6. 8 is less than or is smaller than 10. It means that the 8 is inside the 10. So once the 8 is inside the 10, trace to the variable column to get the median. Once the 8 is inside the 10, trace that cumulative frequency to the variable column to get there. So if you trace, the 8 is inside the 10, so the median is what? So the median body temperature is equal to 36.8 degrees Celsius. That's the median body temperature. Someone will ask that, okay, what if the median position fell on the cumulative frequency, let's say 12. It fell on 12 position. 12 is greater than 1, you skip it. 12 is greater than 3, you skip it. 12 is greater than 6, you skip it. 12 is greater than what? 10. You skip it. 12 is not greater than this, meaning 12 is inside the 13. Then remember, the mistake a lot of people make is that when they get to the 13, if you are not careful, you go and write the 13 as the median. The median will be traced on the variable column. So you trace the median on the variable column. So here, you trace the median down to the variable column. So here, the answer will be your 37.0 degrees Celsius. Now, there is another trick also. There are times that the median position can fall on a decimal. Okay, so for example, you can do, let's say you do the calculation for the median position, and then you had, let's say, 6.5. You had 6.5. 6.5 is greater than 1. You skip it. 6.5 is greater than 3. You skip it. 6.5 is greater than 6. But what you should know is, because it's 6.5, it means some is inside the 6. So it means a part of it is inside the 6. A part of it is inside the 10. Meaning it's in between. So that means that the median position, you are going to trace this and trace this. So the median will be 36.5 plus 36.8 divided by 2. Okay. Now, let's assume you calculated the median position. You had 10.5. You come to the cumulative frequency table or column. 10.5 is greater than 1. You skip it. 10.5 is greater than 3. You skip it. 10.5 is greater than 6. You skip it. 10.5 is greater than 10, all right, but because it's 0.5, what it means is that some is inside the 10 and some is inside the 13. So you trace here. So that will be 36.8 and 37. So 36.8 plus 37, then you divide by 2. You calculate for the position, and let's say you had 13.5. The 13.5, you come to the cumulative frequency column. 13.5 is greater than 1, you skip it. 13.5 is greater than 3, you skip it. 13.5 is greater than 6, you skip it. 13.5 is greater than 10, you skip it. 13.5 is not great, it's greater than 13, but what it means is that some is inside the 13 and some is within the 15. So you trace this 13 here, that is 37.0 plus 37.2, then you divide by 2 to get the median. Okay, so remember, we use this median position formula when the frequency table is on grouped frequency table. The value is 15. Yeah. And it's odd. It's odd. So that is fine. So it's very good. So remember, for median, if you are given on group frequency table, whether it is odd or it is even, still use this position formula. Now the reason is because even if you use the other formula, you choose to use the n over 2 and n over 2 plus 1 position, the surprising thing is you will still get the same answer. You will get the same answer. And I'll prove that to you in the next question that we will look at. Is that okay? So for median in on group frequency table, whether the total frequency is odd or even, still use this position formula. Don't say because of the raw data, the even formula that we learned for the position, you are going to use that two formulas. No. When it comes to frequency distribution table on group data, whether the n is even or odd, still use this formula. You get the same answer. Is that okay? All right. Let's look at the next example. Let's look at the next example. So the next example, all right, so let's look at this example. The next example, we are going to work it out together. So let's do the solution. Let's do the analysis. So we have heart rates. in beats per minute. Can you call out the data? We have 60, we have 65, we have 70, 75, and 80. So I said when they give you the table, the original table, you introduce another column called the cumulative frequency column. You remember that? So you introduce, and this cumulative frequency will be which one? Less. The less than cumulative frequency, or the normal, or the commonest. And here will be the F. Then you also have to introduce another row called the total row. Usually it will not be in the question. You have to introduce that row yourself. Okay? Now let's write the frequencies. The frequencies will usually be in the question, but there are times we can give you a question, the frequencies will be missing. So 1, 2, 3, 4, 2. So let's do the total, but is the total given in the question? Usually yes. But the fact that the total is in the question doesn't mean go ahead and use that total. Compute the totals yourself. So here, let's compute the totals. So we have 3, we have 6, we have 4. That will be 12. So the total is 12. Now the cumulative frequency, the less than, which approach are we going to use? Let's apply the principles first. The first frequency is equal to first cumulative frequency. Here is 1. The last cumulative frequency is equal to total frequency. Here is 12. There is no total cumulative frequency. Put dash over there. Let's use the vertical approach. Here will be what? 3. 1 plus 2, 3. 1 plus 2 plus 3. Here will be 1 plus 2 plus 3 plus 4. 10. 1 plus 2 plus 3 plus 4 plus 2. 12. Is that okay? Great. Now, here we are doing what? Ungrouped frequency table. We are calculating for median. It's ungrouped. How do you know it's ungrouped? The variable column is not in classes. So it's ungrouped. Now, if it is ungrouped, the formula says that the median position is equal to what? N plus 1 over 2 position on the CF. The position of this on the CF. So let's check. What is N from the question? 12. Let's substitute that into it. So we have 12 plus what? 1. All over what? 2. Right? That will give us 13 over 2. That will give us 6.5. Let's go to our cumulative frequency and follow up to the 6.5. 6.5 is greater than this. 6.5 is greater than this. 6.5 is greater than this, but because it's 0.5, it means that some is inside this. Okay? And some is also inside the 10. Let's go over that again. Now, the position that we had is what? 6.5 position. The mistake some student can commit over here is that when they get to this 6.5, they conclude that this 6.5 is the median. No. This 6.5 is the position that will help you to trace the median using the cumulative frequency. So when you get this 6.5, come back and watch or monitor it along the cumulative frequency. Okay, 6.5 is greater than what? 1. You skip it. 6.5 is greater than 3. You skip it. 6.5 is greater than 6 anyway, but because it is 0.5, it means some is inside the 6 and some is inside the 10. Okay, but remember, we don't use this as the cumulative frequency. So you trace here. It means that the median is between this value and what? This value. So the median is between 70 and what? 75. So you add. So 70 plus 75 divided by 2. Can we do that computation? I think you should get something like 72 point what? 0.95 or so. Kindly do the computation for me. And let's see what you get. .5. Is that okay? 72.5. Good. So that is it. But you see, now look at this. This is where your question comes in. This is where your question comes in. Here, the data is what? Even. So you see, if the data is even, you should have used the n over 2 and n over 2 plus 1 position. If you use the n over 2, you get a 70. It will fall on the 70 on the dot because the n is 12. So 70 will be 6. Can you see the 6 is there? The 6 is 70. And the n over 2 plus 1 will be 7. The 7 will come and fall inside the 10. And that's 75. So at the end of the day, you are going to get the 70 plus. That is why the principle is saying that if it's on group frequency table, all the time you use this. Whether even or odd, it will still lead you to the answer. The same answer. Is that okay? All right. Come again? No. Yes, so it's a very good question that you are raising. Median represent position. So median, when you get the answer in decimal, leave it there. Don't try to run it to this. Don't try to apply the discrete and the continuous principles when you are doing median. Because unlike mean and mode, median represents a position. So if you get the answer in decimal, leave the answer there in that decimal. Unless maybe you are running to a nearest decimal, fine, but don't try to run it to whole. So for example, you get an answer like 36.825 in median, then you try to run it to 37. No, because median represents positions. So for median, if you get an answer like this, you can leave the answer in 36.8. That is better than bringing the answer to the nearest, so you end up changing the position because median represents a certain position. Is that okay? All right, that is fine. Okay, so remember the principle is that when we give you ungrouped frequency table to calculate for the median, redraw the table again. You introduce a third column called what? The cumulative frequency. Usually on the original table for the question, total will not be given. You have to add a last row to compute the totals. Is that okay? Good. Then there is a general formula. If it is an ungrouped frequency table, the general formula is this. The general formula is median position is equal to n plus 1 all over 2 position on the cumulative frequency. So when you compute this, so here for this question, for example, n is equal to 12. So you interpolate it into the formula. You are going to get 12 plus 1 all over 2. You get 6.5. Is that okay? Once you are getting 6.5, it's position on the CF. So you come to the CF, then you come in 6.5 is greater than this, is greater than this, but because it's 6.5, some is inside it. Is that okay? But then remember, this is not the median. The median will be on the variable column. The mistake students make is that some of them, when they get here, then some of them will even come and choose the frequency as the median. The frequency is not, the median is not picked here. The median is picked on the variable column. So when you get this, you come and trace the corresponding on the variable column. So here the median will be between the 6 and 10. Some is inside the 6, some is inside the 10. So inside the 6 is 70. And then inside the 10 is 75. So plus 75 divided by 2. So usually when it falls, usually when it is 0.5, it means it will usually be between two, cumulative frequencies. So meaning to be between two values in the variable column. So you add those two values and divide by 2. Then you get the median. Then you add a unit. Usually you have to add a unit to the answer. All right, so this one is the how to calculate for the median when you are given ungrouped frequency table. Ungrouped frequency table. Now let's look at how to calculate for the median. When you are giving, good, it's okay. No, come back to that question. Come back to that question. A very interesting question. Good. Let's keep it on this question. Let's keep it on this question. Okay, so let's look at, this is a typical question for how to calculate for, we can use this question to learn how to calculate for both the mean, which we've done already, and then the median, which we've just done. But you can see this is ungrouped frequency table. But this table looks very interesting because see, on this table, the f of x is given. Okay, this is a table where we have f of x, but then frequency is what? It's missing. So what it means is that the question says that find the frequency for each value x. So find the frequency for each of them. The question goes further to say, calculate for the mean number of patients per day. Find the median number of patients per day. It's a very interesting question. Now, how are we going to get this x? We've been given f of x. So we can draw the table again. We can draw the table. The first column is what? The variable. The number of what? Patients, which is x. The second is what? Frequency, which is missing. The next is what? F of x. Now we have 2, we have 4, we have 6, we have 8, we have 10. What's the total number of patients? Was it given? No, it was not given. But we have f of x, 6. We have 20. We have 24. We have 48. And we have 20. Now, this is a very interesting table. When you are given a table like this, you've been given f of x. How do we get f of x? F of x simply means f times what? X. F times what? X. That is what gives us f of x. Is that okay? But over here, we have the x. Is that okay? The x is given. The x here is 2. The f of x is 6. So what it means is that if you want to get the f of x is a simple mathematics. F of x is equal to what? F times x. Is that okay? So if you want to get the f, the f, how do you do it? You just have to divide here by what? X. Here by what? X. So here, this will cancel this to give us, so f is equal to f of x all over what? X. So if you want to get any of the f's, you take the f of x, then you divide by what? X. So if you want to get this f, you take this f of x, so 6, then you divide it by 2. So let's do for the first one. 6 divided by 2 will give us, so it means here is 3. If you want to get this one, okay, 20 divided by 4 will give us, so here is 5. If you want to get here, 24 divided by 6 will give us, here is 4. If you want to get this frequency, 48 divided by 8, 6. If you want to get this frequency, 20 divided by 10, 2. Very interesting. Before now, you do the total. If you add all together, what are we going to get? 8, 12, 6, 12, 18, 2, 20. Here is 20. Oh, it's 18. Let's do, here is 8. Here is 12, 18. No, 18 plus 20. All right, that is fine. That is fine. Okay, that is fine. So pay attention. So look at this. So it means that the sum of f is equal to what? 20. So now we've gotten the 20, but there is a principle here. Let's assume during your calculations for the frequencies, you had decimal. Remember, frequency cannot be in decimal. So let's assume during your conversion, when you divided the 6 by 2, you had, let's say, 2.5. You convert it to 3. Is that okay? Why? Because frequency should not be in decimals. Is that okay? That is something that you should know. Yes. So for those of you who are not following, let's go over it again. So we are saying that, you remember, this is coming from the mean calculation. The f of x is coming from the mean calculation. And this question is very interesting. So this time they've given you f of x and they want you to calculate for the f. The x is also there. Okay, so what you are going to do is, the principle is f of x. F of x is equal to what? F times x. So if you want to get f, you divide here by x. You divide here by what? X. This will cancel this. So f is equal to what? F of x all over x. Okay, so if you want to get this f, is this 6 divided by 2? Here will be 3. If you want to get here, is this 20 divided by 4? Here will be 5. If you want to get here, 24 divided by 6, here will be 4. If you want to get here, here will be 6. If you want to get here, divided by 10, here will be what? 2. You add all together, you get 20. Is that okay? But now the question says we should calculate for what? Mean. But in calculating for mean, what is the formula? This is ungrouped frequency table. What is the formula? Summation of f of x all over sum of f. Do we have sum of f of x over here? 118. So we'll get mean is equal to 118 all over, the total is 20. Do the computation, what do you get? 5.9. So 5.9, do you have any units over there? 5.9 patients per day. That's the answer. 5.9 patients per day. Is that okay? So now the next question says we should calculate for the median number of patients per day. We should calculate for the median number of patients per day. It means we have to redraw the table again. Or for us to be smart, it means that even before we calculated for this, we should have added the cumulative frequency column to the same table. Sometimes you just have to just be smart a little. So here will be dash. So here will be the CF, right? Good. So now let's do the cumulative frequency. The first cumulative frequency is equal to first frequency. The 20 here will be what? 20. This plus this will be 8. This plus this plus this will be 12. This plus this plus this plus this will be 18. Is that okay? That is an excellent display. Now, this is ungrouped frequency table. What is the formula for median? Median position is equal to n plus 1 over 2 position on what? CF. Now, what is n? What is our n? Our n is 20. So you interpolate that into the formula. You get 20 plus what? 1 all over 2. That will give us 21. 21 over, that will give us 10.5 on the CF. So let's come and trace the 10.5. 10.5 is greater than this. We skip it. 10.5 is greater than 8. We skip it. 10.5 is not greater than 12. It's inside the 12. So we trace it to this side. And that is what? So the median is what? 6. So the median number of patients is 6 patients per day. Is that okay? This is a very interesting question. So this question, the trick is with the fact that they've given you what? The frequency, the FS, and you are to do what? You are to use the FS and the X to get the F. Now let's skip to the next slide. We will come back to the other question. And now let's do grouped frequency table. How to calculate for median in a grouped frequency table. So now we are going to look at how to calculate for median in a grouped frequency table. So look, so in a grouped frequency table, now if we give you a question, how will you even know it's a grouped frequency? You always check the variable column. Usually, like I said earlier, the variable column will always be the first column. So like this one, this is the variable column. Why is it a grouped? Because you see, in the variable column, the values there are in classes or ranges. So you see intervals. So we see we have classes over there. Okay, so this is what to tell you is a grouped frequency table. Now, if we give you a grouped frequency table to calculate for the median, you are going to redraw the table again. This time, you introduce another column that we call the cumulative frequency. So let's do it together. So we are going to draw the table again. You redraw the table again and introduce how many columns? 3 columns. This time there will be 3 columns. The third column you are adding is called the cumulative frequency column. So you are going to have 90. So here is the blood pressure. We have number of patients. Then you introduce what? The CF. Okay? Good. So we are going to have, we have here 90 to 99. We have 100 to 109. 110 to 119. 120 to 129. 130 to 139. Then you have to add the total to it. You have to introduce the row totals. Okay, so here we have 5, we have 10, we have 15, we have 12, and then we have 8. Let's do the computation. Usually to be given to you in the question, but like I said earlier, you have to compute it yourself to be sure. So here, I'm sure if you compute, you get 50. Okay, then you use the principles to get the cumulative frequency. Here will be what? 5. Here will be what? 50. This plus this will give you 15. This plus this will give you 30. This plus this will give you 42. We don't have total for cumulative frequency. Now, if we give you on grouped frequency table, here we are doing group frequency. If you give you group frequency, first of all, you have to calculate for the median class. So you calculate for the median class. How do you calculate for the median class? You use what we call median position. What formula do we use? The formula is n over 2. What is the n from the question? N is 50. So it means the median position from the question n is what? 50. So that's the 50. But when you add the frequencies, you get 50. So that is n over, so we have 50 over 2. That will give us 20 feet. 20 feet value. So you come and check the frequencies for the 20 feet value. So let's check from here. CF is greater than this. CF is greater than this. The position is greater than, is inside this one. So it means the median class is what? The median class is 110 to 119. This is the median. So this is the median class. Okay, so now when you get this median class, okay, you now state the median formula. You now state what we call the median formula for group frequency table. Now the median formula for group frequency table. Median formula for grouped frequency table. The formula states that median is equal to LM plus into brackets capital N over 2 minus cumulative frequency before, close the brackets, all over small f times h. Okay? So where LM is equal to lower boundary of the lower boundary of the median class. Over here, that is 109.5. You just subtract 0.5 from this. You get 109.5. Then the N, capital N is equal to total frequency. Then we have the cumulative frequency before. CF is equal to cumulative frequency before median class. And then the F here represents the frequency of the median class. So the F here represents the F is equal to frequency of median class. Then the H here represents the class width of the median class. The class width of the median class. Now let's interpolate that into the formulas. Let's put everything into the formula. So the median is equal to, what is LM? Lower boundary of the median class. That is 109.5 plus into brackets. What is capital N? That is 50 over 2 minus, what is cumulative frequency before? Cumulative frequency before. Which one is the median class here? What is the cumulative frequency before the median class? This is the cumulative frequency at the median class. Cumulative frequency before the median class is what? 15. Then you write the 15 over here. All over. What is F? F represents what? Frequency of the median class. Where is the frequency of the median class? Then you come and write the 15 over here. But be careful. Sometimes, some of the examples, most of the examples that you are likely to see, usually the cumulative frequency before and the frequency of the median class, they are sometimes the same. So sometimes some people think it's always. You can get a question where the cumulative frequency of the median class and then the cumulative frequency before is different. Don't assume. There is a question that you see the cumulative frequency before and then cumulative frequency, then the frequency of the median class is different. Remember, this is frequency. Okay, then the last one is times what? Times what? H. The H is what we call the class width of the median class. Class width simply means that, look, class width simply means that take 10119 minus the 110. That will give you what? 9. But in statistics, this is wrong. In statistics, if you want to calculate for the class width, the best thing to do is to use the class boundary. Because see, class width simply means class size. Meaning, if you are counting from here, if you are counting from 110 to 119, how many numbers are there? Let's check and see whether it is 9. See, It starts from what? 110, 110, right? 111, right? 112, 11, 114, 115, 116, 117, 118, 119, 110. Let's count and see. No, 120. It ends at 119. Let's count and see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it means that if you use the 9 for the class width, it's wrong. And that is the reason why, if you are calculating for the class width, it is best you use the class boundary. So what is the median class? You see, is this. So the class boundary subtracts 0.5 from the lower limit and add 0.5 to the upper limit. So you see, you are going to get what? 109.5. Okay. Then the upper boundary, you are going to get 119.5. Now subtract 119.5 minus 109.5. Do this subtraction and see. You get 10. So if you want to use this to calculate the class weight, the formula is that if you want to use the class limit to calculate for the class weight, is the lower limit, sorry, the upper limit minus the lower limit plus 1. Okay? The upper limit minus the lower limit plus 1. Is that okay? Yes. So that means that here our H is what? 10. Our H here is 10. So you compute all these things and let's see the answer you get. Compute all these and let's see the answer you are going to get. So compute this one and let's see the answer you are going to get. You can do this one first. Or you can come again. So the median 116.17. And you can add the units. It's what? Millimeters of mercury. Now this one, when you get the answer straight away, that's the median. This, for the group, when you get the answer straight away, that's the median. Let's do another example. That's the last thing we are doing for the median. So let's look at another example. Let's skip to the next slide. Or go back to the previous slide. There should be another slide before this one. Good. Go back to the previous slide again. Okay. So let's look at, come back to the previous slide. Go back again. Go back, 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 back. Good. Next. Good. Excellent. So this is also another grouped table. So you see, when we give you a grouped frequency table to calculate for the median, the same principle. Redraw the table again. This time, how many columns? 3. So the third column you are introducing is the cumulative frequency column. Is that okay? But over here, it's not like the first one, the ungrouped that we just calculate for the median position, then you trace it. Here you have to calculate for the median position to get the median class. You see the first one, there are no classes. So when you get the median position, straight away, you use the median position within the cumulative frequency to get the median. Here, you calculate for the median position to get the median class before you write the median formula itself. So here, we only use the median position just to get the median class. Is that okay? Yes, so you see, so these are the class limits, the classes that we have. So you redraw the table again. You are going to add the cumulative frequency. You do your totals. So these are the frequencies. Remember, I told you, even if the question states that the number of patients is 40, redo your addition again to confirm that it's actually 40. And that is what has been done over here. Then now, after you've done the table, you calculate for the median class. How do we get the median class? Here we use the n over 2 plus, n over 2. But the previous one, we use the n over 2, n plus 1 over 2. That's for the what? The ungrouped table. We use the n, but here we use the n over 2 to get what? The median class. So here we are going to get the total is what? 40. So we get 40 over 2. That will give us 20th value. So let's go to the cumulative frequency. 20th is greater than this, you skip it. 20th is greater than this, you skip it. 20th is inside the 28. So it means the median class is what? 30 to 39. Then you write median class is equal to 30 to what? 39. If I'm the one doing, I'll even do the boundaries and put it down. Is that okay? So usually you need the formula, you need the lower boundary. What is the lower boundary? You just subtract 0.5 from this. So you are going to, so the lower boundary is equal to what? 29.5. Then you do it and put it down. If I'm the one doing, I'll even do the h and put it down. The class width. The class width of the median class, which is the h, and put it down. The h will give us what? The h is the interval, and I told you the best way to calculate for the h is the class boundaries. So you calculate for the class boundary for the median class. So here the class boundary will be 39.5 minus 29.5. That will give us 10. Why are you not going to use? Why won't you use the class limits? Why? What's the reason? If you use the class limit will omit one discrete value. Because see, check something. If you say you are using the class limit, the weight is going to be 39 minus or 30. And that will give you what? 9. But check, in between 30 and 39, it's not 9 values that are there, it's 10. You check and see. 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in between, the class size in between is actually 10, not 9. And so if you want to use this one to calculate, it has to be 39 minus 10 plus 1. So if you want to use the class limits to calculate for the class size or class width, you have to add 1 to the answer. So it will be upper limits minus lower limits plus 1. Either than that, if you don't want trouble, then use the boundary. And because of this, a lot of people get median calculation wrong, especially when it is grouped frequency table. Okay, good. So let's use the boundary, or you can use this. So if you use this, you get 10. If you use this one too, you get 10. So it means our h is 10. Then now you come and write the median formula itself for grouped. Okay, so for grouped frequency table, what's the median formula? Lm plus into brackets capital N over 2 minus CF before all over small f, close the brackets H. Here, if you are not careful, you go and make it plus, you get it wrong, bro. Sometimes a lot of people make it plus, you get it wrong. Okay, yes. Now this L represents what? The lower boundary of the median class. And that is what? That is 29.5 plus. This capital N represents what? The total frequency, which is 40. You write the 40 over here. All over 2 minus cumulative frequency before median class. Come back to the table and check. Where is the median class? 30 to 39. The median class is what? 30 to what? 39. 30 to 39. What's the cumulative frequency before? You see it's 14. Do you remember the first question we solved? Here was 15, here too was 15. But be careful. That doesn't mean, it's this example that I've made it like that. It doesn't mean all the time cumulative frequency before, and then the frequency of the median class is the same. It can change. Is that okay? Good. All right. So we have the cumulative frequency before is 14 all over the frequency of the median class is what? 14. Yeah, someone, where is the frequency of the median class? Yeah, this is the median class. So the frequency of the median class is 14. Cumulative frequency before, this is the median class. Cumulative frequency before median class, 14. Cumulative frequency of the median class here. Cumulative frequency before median class, 14. Frequency of the median class is this. The F in the formula is the frequency of the median class. That is 14. So you come and write the 14 over here. And then the H is what? The class width, that is 10. So now let's do this computation to get the median. $33.79. Remember median, don't rush to convert it. So you leave the answer over here. It's excellent. So, but do we have any unit in the question? You add a yes. Over here, when you get the answer, that is it. So you see here, there are two formulas involved. The first formula is just help you to identify the median class. So when you get that median class, why are you looking for the median class? Because without the median class, you can't get the lower boundary of the median class. You can't also get the class width, because to calculate for the class width, you are going to use the boundaries, the lower boundary and the upper boundary. And that's why the median class is very important. And that's why we use this formula to get what? The median class. Then the median class will help you to get the lower boundary of the median class. And again, remember, you also need the cumulative frequency before the median class, and then the frequency of the median class. That means that if you don't get the median class, there are so many of the values in the formula you cannot get. Is that okay? All right, excellent. That is fine. So let's move on to the next. And good. Come back again. Let's put it on this. Yeah, so I think one of you will come and do this one. You want to do it? Okay. Okay, use this marker. This ones are not working. So you can do it. Mm-hmm.
Okay, so this is the cholesterol level, and then this is the number of patients, what is the frequency, and here is the cumulative frequency. Okay, so from 120 to 139, the frequency is 8. Then from 140 to 159, the frequency is 12. 160 to 179, the frequency is 18. Okay. 180 to 199, the frequency is 14. Then 219, the frequency is 8. Okay. Okay, so to get a cumulative frequency, you are going to use the diagonal approach. So we know that the first cumulative frequency is the first frequency. So here you are going to have the first cumulative frequency to be 8. Then the cumulative frequency for the 140 to 159, you are going to add the 8 to the 12. So you are going to get 20. Okay. For the next one, we add a 20 to the 18 to get 38. Then for the following one, we add a 14 to the 38, getting 42. 52. Okay. Then the last one, we add a 52 to the 8, then we get 60. Okay. So for the total, we know that the last cumulative frequency is equal to the last frequency. So you're going to have 60 for this side. But you don't write the total cumulative frequency. It is not needed. So you put dash there. Okay. So for the question A, we have our cumulative frequency to be 60. So 60. Okay. Okay. Then we come to the next question. It says you identify the median class. Okay. Because there is a group frequency table, we are going to use a formula of the median to be equal to the n over 2 position. Okay. So the n from the question is 60. Okay. So we're going to have the median to be equal to 60 over 2. Then we get 30. So the 30th position. Okay. So we come to the table, the main table. Looking at the 8 is less than the 30. Then we come to the 20, it's also less than the 30. But the 38, this 30th position will fall within the 38. So we trace it to the class cholesterol level, which is the 160 to 179. So the median class is equal to 160 to 179. Okay, this is not a final answer because you have to look for the median value. This is the class for it, so you have to look for the median value. So now the median value has a formula of the lower limit plus the number of into bracket number of frequency divided by 2 minus the cumulative frequency before the median class, all divided by the frequency of the median class times the weight of the class weight, median class weight. Okay, so the lower limit, you are going to, before you calculate the lower limit, you have to know the upper limit and then the lower limit. You take the difference to know the interval between them. So for the 160, you are going to subtract 0.5 from it to get 159.5. Sorry. Let's take the upper limit one. You're going to have 178.5, right? Minus 159.5. So then the answer will be what? 10.
Why are you using the boundary and not the class limit?
Okay. We are using the boundary and not the class limit because if you take the class limit, some of the values will not come.
Yes.
You're going to have, you will omit one value.
And I can ask you that in objective. I can ask you a question that why is it that in calculating for class work, it's not advisable to use the class limits?
So one of the values will not come.
Say that A, class limit will not factor all the discrete values within the class.
Mm-hmm.
Then I can go ahead and say, okay, class limit will factor all the discrete values in the class.
No, there's a mistake here.
No, then the formula there that you're using is for each one. The element is the lower limit, right?
The lower bound.
Yo. This one is for the H. The H, yeah.
So don't write LM.
Oh, sorry.
The class width
Yeah.
of H.
H, yeah. Okay.
And that one is supposed to be
Do the calculation and see.
It's
Subtract it.
179.5. So check. The 178 is 179.5.
Yeah. Okay. You get 10.
Yes, it's 10. So now interpolate into the formula.
Okay. So
Complete substitute into the formula.
okay. So you have the lower limit to be 159.5. So you are going to have 159.5. Then plus we have the total the frequency to be 60. So 60 over 2 minus the class cumulative frequency before. So the cumulative frequency before is 20. So you put the 20 at this side all over the frequency of the class level, a cholesterol level, which is 18. You're going to have 18 at this side, then times the 10.
So you see here the cumulative frequency before, and then the frequency of the median class is different.
Yes, sir.
So check.
Yeah, it's different.
But the previous examples that we saw, they were similar.
Yes, sir.
All right.
Okay. So total. Okay.
So go ahead. We are doing the computation.
165.
So 165.05, and the unit is milligram per deciliter.
Okay, that is excellent. That is an excellent work over there. All right. So can you emphasize on some of the principles you have to pay attention to, some mistakes that you are likely to commit when you are doing these calculations? Areas, if you are not careful, you can make mistakes.
Okay. So some of the areas is from the formula.
Okay.
When you are solving the median value, you make sure you work on the one in the bracket first.
Okay.
Don't go straight ahead and maybe you add the n over 2 plus the lower limit.
Yeah.
So you solve the one in the bracket first. Make sure you get your answer.
Okay.
When you get your answer, you do your multiplication first before you add.
Okay.
You don't add before you multiply.
Okay.
You get a wrong answer.
Okay.
Then this side too.
How about the class weight 2 is something you have to emphasize.
The
class weight 2.
Yes. The class.
Not careful. You use the limits. You don't add plus 1.
Yeah.
This is also another area you can get it from.
Yeah.
And then how different is this from the ungrouped frequency, the median?
Okay. So from the ungrouped frequency, for the median, the formula you add plus 1.
Right. Okay. Let me see.
Okay. You're going to have the median to be n over 2 plus 1.
No. N plus 1 over 2.
N plus 1.
Yes. So n plus 1 over 2 plus 1 over 2.
Okay.
Position.
All right.
Is that okay?
Okay.
That's fine. All right. Okay. So well done. Skip to the next question and then we can pause.